Have you ever looked at a complex app or a massive video game and just wondered, how did they even begin to build that without it turning into a total mess? Well, it's definitely not magic. The secret, it turns out, is structure. So today, we're going to pull back the curtain and see how to tame that code monster using just a few surprisingly simple tools. Okay, take a look at this. This right here is what programmers call spaghetti code. And you can see why, right? It's a complete nightmare. The lines of logic are tangled, confusing, and if just one little thing breaks, well, good luck finding where the problem even started. This is the monster we're talking about. That sounds kind of impossible, doesn't it? But it is absolutely true. Every single piece of software you've ever used, no matter how complicated it seems, is built from just 3 fundamental patterns. See, the solution isn't about fighting the chaos. It's about using structure to make sure the chaos never happens in the first place. So let's properly meet our villain, the spaghetti code monster. Because unstructured code like this isn't just ugly to look at. It's a huge practical problem for anyone trying to write it. And this slide really breaks down the problem perfectly. When the logic is all tangled up, it's almost impossible to follow what's going on. That, of course, leads to way more errors. And trying to fix them, what we call debugging, becomes an absolute headache. And for a team trying to work together on this, forget about it. It's a recipe for total confusion. But okay, that's the problem. The good news is we have 3 heroes that can defeat this monster. These are the fundamental building blocks that bring order and sanity to the world of programming. And here they are: sequence, decision, and loop. That's it. Really, every single program you use is just a clever combination of these 3 simple structures. So let's break them down one by one. All right, first up is the simplest, most intuitive building block of them all, the sequence. You know, the best way to get this is to think about a recipe, like for French toast. You can't toss the bread in the pan before you've dipped it in the egg mix, right? You have to follow the steps in a specific order, one after the other. That, in a nutshell, is a sequence. So to put it a bit more formally, a sequence is just a series of actions that happen one after another. There's no jumping around, no skipping steps. It's just step 1, then step 2, then step 3. It's linear, it's predictable, it's simple. And this is pretty much exactly how it looks in programming. Now, you don't need to understand the words, just see the pattern. The computer does one command, then it does the next one, then the one after that. Exactly like our recipe. Okay, so that's block 1. Now for block 2. This is where programs start to get, well, a lot smarter. It's time to introduce the decision, which is also called selection. Life is just full of choices, and programs are too. This is such a perfect real-world example. Based on one simple condition, do you have an umbrella, you take a completely different path. This is the core idea of a decision. Essentially, a selection structure is all about asking a simple yes or no question. Is some condition true? If yes, we're going to do this. If no, we're going to do that. This is what gives our programs the power to react differently to different situations. Now, decisions kind of come in 2 main flavors. You've got your single alternative, which is super simple. If it's hot, you turn on the AC. If it's not hot, you just do nothing. Then you have the dual alternative, which gives you 2 distinct paths. If you have a car, you drive, else you take the bus. Both are incredibly useful. And in the world of code, this logic usually shows up with simple keywords like if, then, and else. Again, the exact words aren't what's important here. The key is understanding that the program is asking a question and choosing a path based on that answer. All right, we've covered order. And we've covered choice. Let's get to our 3rd and final block, and this one is a real game changer. It's the one that gives programs their incredible power and efficiency. The loop. I want you to picture climbing a staircase. You don't have a separate instruction for every single step, do you? No, your brain just uses a simple rule. As long as there are more stairs in front of me, I'm going to keep taking steps. That is a loop. A loop is basically a program's automation engine. It takes a bunch of instructions and just repeats them over and over and over until a specific condition is met, like, reaching the top of the stairs. This is how computers can do thousands or even millions of things in the blink of an eye. And just like with decisions, the code for this is super intuitive. It often uses the word while. So while some condition is true, the computer will just keep repeating the actions inside that loop. It's simple, it's powerful, and it's absolutely essential. So we have our three blocks: sequence, decision, and loop. Now for the really cool part, the magic. How do we go from these three simple ideas to building, complex software? It really comes down to two main tricks. The first is stacking, which is just putting structures in a sequence. Do this loop, then make this decision. The second one, nesting, is where the real power comes from. You can put a loop inside of a decision or a decision inside of another decision. By stacking and nesting these three simple blocks, you can build logic of any complexity you can imagine. So why do we go through all this trouble? What is the big payoff here? Well, it's huge. Using these structures makes code clearer and so much easier to understand. It means if you have to make a change, you only do it in one spot. It lets teams work together without stepping on each other's toes. And most importantly, it all leads to better software, built faster, with way fewer bugs. We've tamed the monster. So I want to leave you with a little thought experiment. Think about your morning routine. Getting ready, making coffee, deciding what to wear based on the weather. How would you describe all that using only a sequence of steps, a few if-then decisions, and maybe a loop or two? You might be surprised to find out that you're already thinking like a programmer.